Hello everyone, Hafsa here, and today we're going to talk about effects in animation. Up until now, we focused on animation of characters and objects that have a rigid and constant form and behave in realistic manner. But animation is actually way more than that. Morphing, shapeshifting, magic, fire, water, explosion, and even moving inanimate objects, all of them is something that is quite common in animation. And they give you a lot of creativity and personality whenever you're trying to add something interesting to your project. Not to mention that effect animation looks quite impressive as well when it's well done, and really sells the impressions of your scene, or even can be the focus of it if they are interesting enough. Today I'm going to teach you about effects and showing you examples of simple materials that you encounter a lot in animation. FX or VFX are the acronym of visual effects in animation. This is the symbol that you're going to see written whenever there is an effect involved in your shot. These are additional animated elements which add detail and impact to a scene, and they can be also used to give your entire scene a more realistic and grounded feel, as well as sell the impression of your character actually interacting with the environment. These effects can either be environmental effects that are part of the background, such as rain, smoke, water bodies, fire, etc., or they can be motivated by the character action themselves, such as having magic or interaction with the environment when stepping or when going into out of body of waters, interacting with different objects, etc. There are also effects that come directly from the character, such as tears and wounds. The way that we design and animate the effect will really change the overall look and mood of the animation. Your effect needs to both fit the character design, work with the background, and be readable to the viewer, while keeping its purpose of adding detail and liveliness to a scene. Effects follow the same animation rules and techniques of any other object that we've animated so far. They are still going to be affected by the same environmental forces, such as gravity and friction, and be animated with the same animation rules as the ease in, ease out, and smear frames that we've done before. You will use the same timing patterns to sell the actions and movement of your effect, as well as use the same types of techniques that we've done with any other animation, such as smear frames, impacts, and delays. But because effects usually don't have just one simple, rigid shape that we can refer and divide into parts, they're also going to be moving a lot more like character details than actual concrete objects. Also, a lot of the time your effects are going to be energy and force sources themselves, so they're going to move in ways that are unusual and that we haven't seen before. Most effects will move using a wave pattern, similar to the way that we've done with the animation of objects in the last lesson. The main difference is that most effects don't have the rigid structure of the character details, and their waves don't result from tension, and thus they will have more random changes in the overall shape of the effect, with greater flexibility in morphing and overall different timing than what we've seen before. I like to divide the wave patterns that I'm using into 3 simple types. The first type is the blob, which will appear and change size from the beginning to the end of the animation loop. I usually use this type of blob animation with fire or energy effects, because it seems like it's coming in actual waves or pulses. And you can have a lot of variation with the timing of each individual blob. Will let you have a lot more interesting effects because it would still seem like it's moving even when the timing is delayed or randomized. The second wave pattern is the S-curve. This is more similar to what we've seen with the tension, But unlike tension, we don't need to have a concrete and repeating pattern for the tension points, because, well, we don't have tension. Here we just make a random wave, but still keep the entire movement consistent. So you don't get to just randomly change the size or the shape of your movement, and you do need to follow a concrete and constant starting point in your wave. The last pattern is the random wave, which is basically a combination of the two previous wave type. With this, you can both create pulses and changes and shifts in direction of the entire effect in a way that creates more randomized and natural looking effects. This type of wave pattern is a little bit more complex and you can play a lot with it, and I mostly use it when I want to create more detailed effects such as realistic looking fire or any type of detailed water and spray effects. This type of wave is typically characterized and recognized by the large amount of shifts in the entire volume of your effect. Basically, with this type of wave, you can kind of do whatever you want as long as the entire movement looks coherent. Once again, the timing of the wave pattern is what is going to give your animation energy and personality. So faster wave will create more energetic effects in comparison to slower pace, which will give a calmer and smoother appearance. Also, with effects, it's actually more interesting to combine different frame rates on different elements of the effect. With effects, you can use both 2s, 3s, and 1s, but I personally recommend only using 2s and 1s, because the effects will have large amount of change between each frame, which looks better with higher frame rate since you're trying to use a lot of quick movements. You can also create main movements in 2s and add additional details in 1s, which creates a really interesting effect when you're making your animation. Or you can alternate between 1, 2s and 3s in the actual effects to give emphasis to certain shapes which looks nicer, as well as play around with the timing and make your overall animation more interesting. For this, you will need to separate your effect layer into separate layers, with each frame being duplicated a different number of times to achieve different pacings between layers. In conclusion, when trying to animate your effect, you need to really think about the implications of the movement that you're trying to make and the internal properties of your object's material. You really need to think about which forces are acting on your effect. Usually it's going to be gravity, but air resistance or internal tensions are going to affect the way you'll animate it as well. And with taking into account your shape design and the purpose of the effect in your scene, you will need to make changes to the overall timing and size and details of it. The real important thing is to make sure that the effect tells the idea clearly. If you want your character to interact with the environment and put around dust clouds, you don't want the dust to overpower the actual action. If you want to have a magic effect, it might be the focus of the scene, so you want to make it much bigger and more noticeable than what you will normally have. If you want to sell the illusion of power or inherent friction or characteristics of the effect, you might want to use delays in certain frames so the audience can have a clear view of it. And if you want to sell the idea of your effect having a lot of force behind it, you might want to actually make it affect the environment. Each decision, such as this, will determine which wave pattern you're going to use, which design shapes, and which timing and techniques that we've used in the previous lessons are going to fit best with what you have in mind. And always remember that by playing around with the timing and trajectories of your effect and creating multiple variations to them, you will create a more interesting and aesthetically pleasing effect. You really don't want your effect to bore your audience. So shifting your effect around and even making it less realistic just to sell the impression of it is better than having a repeating effect which is boring and distracting. The next thing to consider when animating your effect is its shape design. Your shape design is going to affect the overall look of the animation and the type of wave pattern that is best for you to use, because not all types of designs are going to work with all types of patterns. If your design is too smooth, it might look weird with a randomized pattern, while if your design is too random, making a smooth or constant pattern might make it look weird or very repetitive. This kind of mistakes in the design and wave pattern can result in very distracting and unpleasing animations. So it's important to match the shape to the type of effect that you're trying to create. Your design also needs to fit the overall art style of your project and background. For example, a more detailed and realistic effect will not work well with extremely stylized animation, because it will feel jarring when compared to the surrounding, especially if it's a background effect. In comparison, a very stylized effect on an otherwise realistic project will still be jarring, but it can also result in a very unique effect where you seem like you're taking advantage of the medium of animation and creating something that is otherworldly in your regular environment. This is often seen with magic effects, but this also means that the effect would not seem like it's part of the environment or the regular world. So you need to use this type of change in style wisely, depending on the setting of your project. It can still be an issue when trying to animate effects in actual environment, because they might not match the style of the background, or they might break the audience's engagement. The best way to design your effect is actually to match it to the background. So first, you need to understand the shape language and art style of the background, and then match your effect to it. So if your background is composed of a lot of very realistically drawn details, making your effect more realistic is a better choice. While if your background is composed of very simple shapes or very flat composition, it might be better to make your effect more shape-based and make it more stylized. Extremely stylized effects in an otherwise realistic environment is still acceptable, but you do need to understand the implications and risk to it, as well as make sure that it still looks pretty in the frame and not too distracting. Once you have the shape design of your effect, you need to think about which pattern will make it look best. So if you know that your design is more a pulse-like animation, it's better to use something like a blob or a randomized wave pattern. But if you have something that is more long and calm, it might be better to use the S-wave pattern. You can see this more clearly when you're trying to animate water, energy, wind, or any other type of rhythmic animation. The duration of the effect on the screen is also important when deciding which wave pattern and shape design you use, because if your effect is constant, you want something that can be made into a loop. But if you're only showing the effects for a one-time use, or if the effect itself is more like a pulse, you want something that can start and fade. So, for repeating animation, you can use either wave, but for something that works like a pulse, using the blob specifically is more useful, because you have a very clear start and ending point for your effect. After you decide on your shape design and wave pattern that you're going to use for your effect, it's important to know what timing you're going to give it. Now, even if your animation is a loop, or if you're trying for a single pulse, you still need to know if you want it to move slowly, quickly, accelerate, decelerate, or create any other type of complex trajectory. For this trajectory, we're going to use the same methods as we've done before, with the same acceleration patterns of ease in and ease out, as well as trying and make the entire effect follow a single point with the center of mass method, even though the effect itself might not have a mass. You can still break it down into simple parts depending on how much movement you want to have in each individual one of them. You also need to match the type of wave patterns along the entirety of the effect. So if you have something that is quite big on the screen, such as animating water or any other liquid in the environment, or having a very big fire or wind which affects the entire screen, you want to divide each individual part in the effect into its own small animation which follows its own trajectory. This will give more variation and more interest to the overall effect. But what you also need to consider is that the amount of detail affects the timing of your animation. Because if you want your effects to be clearly seen and understood by the audience, the more details you're going to give it, the more frames you want to use to show it. This, of course, clashes with the idea of using the timing to show the energy and the overall movement of the effect. But because you have more details, it actually might work better to slow down and elongate the timing on certain parts of the effects that you want to give emphasis to. Otherwise, you might not be able to actually see the effects correctly. So here, unlike where we're animating objects which are more rigid, we might want to stretch reality a little bit, just to give emphasis and a more aesthetically pleasing look to the animation. Here you can see that if I want to sell the effect of the water drop having more details, I need to lengthen the entire effect a little bit, just to give us more time to actually properly animate each part of the effect. But when the water drop is a little bit more simple, it's okay to make it move quickly because you don't need to absorb quite as many details. The inherent properties of the materials that you're animating are also important for deciding the timing. If you want to show a certain characteristics clearly, you need to give enough time for the audience to see it when adding animation of effects with a lot of details. So for example, if you want to show something that is more powerful or something that has inherent elasticity, you might want to add a delay on the important frames that clearly show that effect. So again, you're going to stretch the timing a little bit, just to make sure that the idea of the effect itself is communicated effectively. When it comes to animating your effect, you need to consider both the properties of the material of the effect, the wave pattern that you're choosing to represent these properties, and how your shape design is going to affect your timing with the amount of details and wave patterns that you've chosen. Different types of materials will behave differently depending on their own internal properties. By understanding where your effect originates from, what inherent properties it has, and what are the forces that affect the effect in the surrounding, you can predict the trajectory the effect will take and use the correct timing, spacing, and wave pattern. I'm going to be demonstrating this idea with a couple of examples of different types of materials. Starting with a fire blast effect, here I chose to have a fire which originates from a single source and works around the screen in a pulse pattern. Here I'm going to make the fire disappear after the initial pulse, but if I wanted to make the fire stay on the screen for a longer period of time, I would have chosen a pattern which allows for repeated movement, such as the S-curve or a repeated blob, as opposed to a single blast. It also means that I would have kept the entire effect a little bit more contained because I would want to be able to clearly tell where it starts, finish, and is present at every single moment of its appearance on screen. A fire blast is kind of similar to a ball throw because it only has force propelling it at the start of the movement and the rest of it is continuing to do the momentum. This means that the fire is going to deaccelerate while losing its energy. And because it loses its energy, it's going to expand more and more while losing the original trajectory. Because the energy of the fire itself needs to disperse into the environment. Because this fire doesn't have a fuel source, it's going to disappear when losing its energy. So basically, I'm having a pulse or bulb wave pattern with a small concentrated fire at the beginning that slowly fades into the environment before completely disappearing again. The reason I chose a pulse wave pattern in the first place is because I knew I wanted the fire to originate from a single small point, expand, and then disappear into smaller points once again. You can apply this reasoning to any type of effect that you want to create and just match the wave pattern to the idea that you have in your mind, even if you don't want to think about the realistic implication of the effects and the materials that it's made out of. For a second example, let's try and animate water. Water has mass to it, and this is expressed by using more traditional animation rules, which keeps the entire object more rigid. But unlike solid objects, the water tension is not strong enough to keep its shape when it experiences an impact. This requires a morphing of the original shape of the water. So this time, we're basically going to divide the water blob into several different parts with their own mass, according to the trajectory and the overall state of the water during the impact, for each individual frame. So when the water first hit the ground, it's going to lose some part of its energy, which is going to affect its trajectory. The part which hits the ground is going to stick to it, while the rest of the water is still going to move due to momentum. So what we're going to do is actually split and stretch the water across the floor as long as the water is still being impacted and is moving, until each part of it is reaching the end of its trajectory and settling down. You need to make sure that each part of the water that is still moving is continuing the same trajectory as before, because there is no new force which is acting on the water at this stage. Next, we have lightning. Lightning, similarly to fire, is an energy source itself. But unlike fire, it holds too much energy and it's not going to lose its shape or strength relative to the distance from the source, but by interacting with other objects and discharging the energy into them. The lightning will only cease to exist when the electric energy itself is completely discharged. So we're going to show the effect both in its shape, its timing, and the effect that it's going to have on the environment. If we don't show the environment, we're just going to make do with the timing and shape of the lightning itself. Lightning travels much faster than fire, and it actually cannot be fully expressed in a low frame rate, even if we're doing big spacing between each frame. For something that moves quickly or has a lot of force to it, I use ones, as in animation at 24 frames per second. But I still want to have a very clear trajectory and wave pattern to the lighting, even if it does move quickly. To make it easier for the audience to see the trajectory, what I'm going to do is make the overall movement on 2s, but then divide the timing on 1s and make it flicker as well, to make it seem more energetic. You can play around with the amount and speed of the waves when adding the lighting to create different types of effects, as well as playing around with the overall timing of the camera. If you want to show the power of the lighting, even without flickering or with slower frame rate, you can show it by comparing it to the speed of other objects in your scene. Basically, you can try and make every other thing in your scene move in slow motion, and the lighting moving in regular motion, to sell the impression of the lightning moving a lot quicker than any other thing in your shot. The important thing about animating lightning or any other effects with a lot of force behind it is to have a very quick originating point and then emphasizing its strength by having more frames dedicating to showing it at its full size. Wind, similarly to lightning, is a force which actually directly affects the hair itself, meaning that it will not be dispersed by interacting with the environment, and it can travel large distances quickly. The wind itself does not have a one shape, but it will act in accordance to your chosen pattern. With wind, you can use blobs patterns to show pulses of wind, to show a wind which is constantly blowing and affecting the environment. You can also have a combination of them to show both your character actions and the environment around them in a more interesting way. I personally like to combine both the effect that the wind has on the character with an S pattern and also show the strength of the wind by using pulses. The wind is also much quicker than any other thing in your scene. So I personally like to animate it on ones and also add smear frames to it. But unlike lightning, which is very much a focus of the scene whenever it is present, the wind usually is going to only be accompanying the environment and backgrounds to sell the effect of your characters interacting with it. So you still want to create a design which is not too distracting, even with smear frames. Another type of effect that you're going to see quite a lot, especially in realistic animation, is spray. This is the case where the liquid does not have enough internal strength to keep its initial shape together. This will cause it to split into multiple different smaller parts, which are affected by air resistance. This is basically the liquid version of the fire effect that we've done at the beginning. Instead of having a small originating point expanding and then disappearing, the spray effect is going to switch and combine between the water effect and the fire pulse effect that we've done before. But instead of keeping its shape until it hits the ground and expanding and then disappearing slowly into the air, the spray effect is going to expand while being in the air, and it's still going to move downwards even when breaking into smaller parts. With spray, you want to have quite a lot of details and little dots, because we want to really show that each one of them has mass. You don't really need to keep track of every single particle, but it will help your animation look better. In this lesson, we have multiple options for exercises. You can either follow along with this video and create new effects from scratch as a beginner, or you can actually take the previous exercises that we've made in lesson 10 and convert them into effects. So basically, you take the timing and the motions that you had before and try and put an effect on top of them in a realistic manner, while keeping in mind how the motion of the object itself is going to affect the effect. Again, keep consistency and good line quality when creating this exercise. And you can make as many of them as you want, with many variations. For extra difficulty, try and combine these effects with the character animations that we've made in the last exercises, if their motion allows it. To recap, today we've learned about how effects are animated using different wave patterns and how the design of your effect and the timing that you want to give it are going to choose for us which pattern it's best to use. We've also learned about how to analyze what idea we have in mind and how to apply it to the correct wave pattern for our animation. And lastly, we've learned how different objects and material properties might affect the way that we're going to animate the effect. And talked a little bit about customizing the timing and look of the effect in order to match the selling point and idea behind it. Next lesson, we'll finally start looking into cinematic animation with animation in perspective. Thank you for watching and see you next time. Bye!